Hello everyone. Continuing on our previous discussion, now we will understand how to invoke these Bedrock, APIs, or you can say through the Python SDK, how to do all the functionality that we did in the playground. So I also have some code here, so we'll do this hands-on, and I'll just walk through it, and it's pretty simple to start with. So we are just importing the different libraries that we would be needing in Python. We are using .env because our access key and secret key of AWS actually lies inside the .env file, so it will automatically put that for the Bedrock. And here I'm calling the initial simple API. So what I'm doing is, first I'm selecting the AWS region, then creating a Bedrock client, which is a Boto3 client. So Boto3 is the de facto library whenever you are working with AWS. And what you need to do, it's pretty simple to use. You just need to provide the service name. Here I'm providing Bedrock. I might use S3 tomorrow or anything. So Boto3 is, I think, the best of the worlds there. And here you just need to provide the region name. Now all the different functionalities that are available with Bedrock would be available to this Bedrock client, like as an example, list foundation models. So what this would do is, this would give you all the different models that are available. So I'm calling this function, so it's actually going to the AWS, getting all the models from the model catalog that we have here, and returning the summaries. And in model summaries, you can see what all data we are getting. We are getting the ARN, we are getting the ID, model name, input modalities, whether it expects text or image as input, and what would be the output, because this is table image fast upscale. So this would take in an image and text, and it would produce another image. So correspondingly, you have whatever foundation models are there, all would be available through this foundation model list foundation models call. Now this is the basic, but what we would actually want to do is, we would want to mimic all the things that we did in the playground inside this code. So for that, we would, instead of creating the Boto3 client of Bedrock, we would create for Bedrock runtime. So this is actually when you want to work with these foundation models. So that is for getting all the metadata, but here you are actually getting your hands dirty by interacting with these various models. So what you are doing, Bedrock runtime, again region. So here region is very important, because all these models are deployed in different regions. So if there is some regulatory instances where you are not allowed to share your data outside of, let's say, your country or your region, so in that scenario, this region actually plays a very important role. And here we are simply choosing the model ID. Here I'm playing with Amazon Nova Lite. You can actually play with any model. So if you see, I'm using this Amazon Nova Lite. You can also go inside this, understand about the model. You can see the inference parameters, responses, some examples. So a lot of stuff is also available readily by from within the AWS console, as you can see. But yeah, through the Python way, I think this is how we eventually would be doing all the stuff. So this is, I think, a good starting point. And what we are doing is, we are putting in a user message. We are saying, describe the purpose of a hello world program in one line. So we are not putting any system prompt or anything. We are just starting simply with a user message. So user asks this. So whatever was the default prompt for the model, or whatever the model has been trained on, that would kick in. If you want, you can also put in a system prompt, so that's also totally possible. And what we are doing, we are building this conversation. So what this conversation is, this is a list of dictionaries, okay, and within every JSON dictionary there is a role and content. Okay, the role is basically, let's say the user is saying what is the assistant saying, what is again the user saying, what is assistant saying. So we maintain the entire conversation in this format. So if I'm saying, describe the purpose of hello world program in one line, this is what the user is saying. Now the next response that I would expect is an answer to this. But if there was a conversation that I would have passed, so the model would have taken that into consideration. Okay, so the user has been conversing around this topic, now it's asking a follow-up question, so let me kind of keep that thing. We'll go into the details of that also, but to keep this session simple, I've just started with a user message, and on top of that we can call the Converse API. Now the interesting part is, this Converse stays same whether you are calling different foundation models. So this is pretty flexible from that perspective. You just need to provide the model ID, the conversation, and the inference parameters for that model. So the max tokens, we had seen this. So this is the maximum tokens that were being used in the output. Then the temperature, this also we had seen that temperature actually tells us that how the model is smoothing on the output tokens. So if we increase the temperature, there is a higher probability of getting different answers. Top P is just a filter of how many percentage of the top responses of the entire tokens that we have, that is actually coming in the output. So this is also, if we decrease top P and we decrease the temperature, the model would be more consistent in the responses. But if we increase the temperature and top P, the model will be more creative in the responses. So that's the basic parameters that we had seen in the playground as well. And this API call that we would be making, this would be actually going to this Nova deployed somewhere in AWS data center. It, the transformer model runs, it generates the response based on the conversation that we are passing, and actually the response is then stored as a JSON dictionary again. And from that JSON dictionary, we need to extract the response using this standard format. So mostly you would see that you would have the output first, then the message, then the content, then the text. So actually we get a lot of different stuff, like what were the tokens used, time taken, and a lot of metadata around that API call that we made to the Nova model. So that's why this is actually structured in this way, and we need to extract our response. We can also see what was the exact response. First let's see, print the response. Okay, so we have the response here. Then we would see, let's just do this. Let's see. Oh sorry, here would be, it would be new lines, right? So I'm making the call. You can see this is the request ID, this was the date when the response was made, Amazon request ID. Then inside the output we had the message, then role. And similarly, earlier the role was user, now the role is assistant, because the model is now responding. And within this you would have content, and within content there is again a list. From list we are getting the zeroth element, and within that zeroth element we have text as the key. Stop reason, end turn, usage, how many were the input tokens, output tokens, and all that. So this metadata is actually also coming along. What was the latency? So it took around 344 milliseconds for the entire response that it created. So this is actually the converse, where we are getting the response in one go. But actually how a transformer model works, it generates token by token response. So it is sequential when it is inferencing, but it's not sequential when it's training. Because it's sequential when it's inferencing, so we can also stream the response. So rather than waiting for the entire response to be generated back and then returned, we can also stream that. We'll see in later scenarios that streaming actually helps the time to first token. So that's an important metric when we measure different models and deploy these solutions, because it should be fast when the user starts to see. So whenever we are using ChatGPT or any other model for that fact, we actually start seeing the response, so it builds, okay, at least the model is doing something, rather than waiting for 2 minutes for the model to first generate the entire response and then only come. Because here it's a simple scenario, so it took very less time. But yeah, I think streaming is an important aspect. Streaming, async operations, these all also we would see when we would see more services. Now there's another class of models, we can say these are the embedding models. So what they do is they take in your sentence and they actually convert that into a numerical representation. So here we are using Amazon Titan text embedding v2. Again we create the same client, but here the model ID changes. And because this is an embedding type of model, so we don't use the converse, because here the converse won't work. This is not a foundation model in terms of which expects text as input and returns text as output. But this is an embedding model which would expect text as input, and it would actually spit out the embedding of that text as the output. Okay, so embeddings can also be for videos, for images, for text. So the what happens is, for the transformer model to understand anything, it cannot understand text. Text has to be transferred, or you can say translated into numerical representations. Now we simply don't just assign any token or any numerical representation to the text, or tokens combination of token sentences. So what we do is we have a smart way, that is by converting them into embeddings, and these are these embedding models, which are again, you know, large models that have been built, and these are hosted, which help you in implementation of RAG kind of pipelines generally. So we are mostly, these embeddings are used when you are actually deploying these RAG, because in RAG you create these vector embeddings, you store these vector embeddings inside some vector store. We would see it can be S3 nowadays, it can also be the Bedrock knowledge bases, Kendra OpenSearch. So you can store these embeddings, and in real time whatever the user is querying, so you that query can be actually referenced across the embedding, so that the closest matching response from your knowledge base would come into the model's context, and then we can respond. So we'll see all that. Here I'm just telling the power and importance of these embedding models. We'll definitely be using them. So very easy, we are just providing an input text, and that input text gets converted into the standard embedding. So there would be an embedding size of every model. So here you can see the size is 1024. It varies from different embedding models. These can stretch out to 4000. These so that's the length of the array that it's outputting. Okay, and I also have a nice visualization. You can see the embeddings actually does what. So in 1024 dimension space, it is actually separating out the different sentences according to their semantics, according to their meaning. So here this is a simple example, that wolf, dog, cat, these are somewhat related, versus apple and banana. So they are lying in a different space of this hyperplane versus these three. Similarly, we have an hyperplane of 1024 dimensions, where we are segregating these different concepts, so that the model is able to understand, okay, if someone is talking about dog, so it's closely related to cat as well, versus if someone is talking about apple, it's not that closely related to dog. Plus there are also some relations that exist in this embedding space. Okay, embedding vector space, that the distance of, let's say, king to queen would be same as distance of, not exactly same but similar to man versus woman. So all that semantic relationship, everything is being captured in this vector embedding space. So that's the beauty of it. And what we are doing is we are just using the client.invoke model. So this is also a standard Bedrock request. With the above also, we earlier we used to use invoke model only, but now AWS has come up with this easier Converse one, which is, I think, uh, better, because it works smoothly with every model. Invoke model mostly now we are using with the embedding model. So again, model ID request is expecting input text. Inside input text as key, we are expecting whatever is the sentence. It can be a word, it can be a sentence, anything. And then you are getting the token count and the embedding vector. So you can see this is the exact vector. Okay, so this is how we can, an introductory to Bedrock, accessing through the Python SDK Boto 3 specifically.